So yesterday we had looked into the parallel in serial out configuration, isn't it? And we had seen that with the help of this shift and load function, we were able to either shift the values from one flip-flop to another flip-flop, or just directly load the values through the help of AND gates, right? So I hope this concept was clear with all of you, isn't it? Okay, so moving on, now we will look into, yes, so this is a generic representation of your 4-bit parallel in serial out configuration. Okay, so here you have your inputs as D0, D1, D2, D3. Okay, let's assume that we have given these as our inputs. Okay, 1 0 1 0. Okay, so as you all know, it comes out as D0, D1, D2, D3. Okay, so which means it's the reverse way. So you can find that. Okay, so using our clock, so here either if it's high value, then it's going to shift. If it's a low value, then it is going to load. So based on that, we have the values here, the data input values, which is 1 0 1 0, and our clock is given, is enabled, and then we get data out via Q3. So which means Q0, Q1, Q2, Q3. So clock is given, so which means this is positive edge triggered clock, right? Positive edge triggered clock, rising edge clock, right? So based on the operation of shift and load, okay, so based on the high value and low value, it can either shift the value or it can directly take the values from the inputs which were given D0, D1, D2, D3. So you can see that we have 0, 1, 0, 1, 0, 1, 0, 1, right? So those are actually appearing across your outputs, right? So you have your D3 here, D2, D1, D0, okay? Because the values would have passed um, from one point to another point because of the clock cycle, okay, and ultimately outside. So which means D0 will come out first, right? So D0, D1, D2, D3, right? Okay, so any doubts here, students? Students, any doubts, or can I proceed?
No, sir, no doubts.
Okay, fine. So now we'll look into a different configuration, which is your parallel in, parallel out shift registers. So here you have data which is entering in parallel. So this is your data in, and the one which comes out is your parallel out. Okay, fine. So the data bits are entered simultaneously into the respective stages. Immediately, the bits appear on the parallel output. So that is the property of data in and data out, which is parallel in, parallel out. So immediately, as soon as you have your data uh, given, so that would appear instantaneously at your output. So unlike previous versions, here we do not have any connections from one flip-flop to another flip-flop, right? See, your Q is just taken out. Q is not connected to another flip-flop. Let us get back and see the previous connections. So you will be able to understand that Q is actually connected to the next flip-flop via AND gate, right? So which means Q naught will get inside here through the OR gate, and then it would come out like this, isn't it? So you can see that there is a connection here. Yes or no? Yes, students respond. Correct?
Yes, sir.
Yeah. Right. So this is the way your data passes through from one flip-flop to another flip-flop. So this was in parallel in serial out. Now when I go with parallel out, okay, which means this serial connection has to be removed, right? The serial connection has to be removed. So in order to do that, I have to cut short all of these connections, which means there should not be connections from one flip-flop to another flip-flop, right? So that is what we are trying to achieve in parallel in and parallel out. So that is what you can see here. As soon as the data enters in, the same data comes out. Okay, so you can see here that your output, okay, Q naught is actually not connected anywhere. It is just taken outside. That's it. Okay. So similarly, data are given in the form of D naught, D1, D2, D3. So all this data gets inside. Since it's a D flip-flop, you know that if a 0 is given, then 0 comes out as the output. If 1 is given, then 1 comes out as the output. If this is my X and Y. Okay. So any data that I given, the same data comes out as Q0, Q1, Q2, Q3. Clocks are the only thing that is connected together. Okay. And as soon as I enable my clock here, so all the flip-flops together will be enabled. Okay, so it can be 1, 2, 3, and 4, all will be enabled. Suppose I do not give a clock, then everything is going to be disabled together because they all are connected together. They have a common line. They have a common line, right? So is this clear? Can I move on?
So what would be an application for this?
The application for this, uh, parallel input, parallel output. Maybe we can say your patch cords are there, no? Patch cords. Are you aware of expansion ports? Or probably, okay, let me say, mm, you have a small laptop, okay? But then it's a powerful laptop, but you want to connect it to a bigger display, okay? So in that case, you will be using an extension cable, which connects from your laptop to the monitor, the extension monitor. You're understanding what I'm trying to say?
Yes, sir. Yes, sir.
Huh? So in that case, all the data will be parallelly moving from your laptop to the monitor. For example, when you're gaming, okay, maybe you have bought a good gaming laptop, your hardware is good, you have good graphics, good RAM, okay, good memory, everything is fine, good processor. But then you find that your display is too small. So what you will do, you'll probably purchase a big curved Samsung display, normally that you get. So you can actually connect your laptop to that display, and then you can comfortably use for gaming or any purpose or entertainment or anything for that matter. So in that case, this parallel in and parallel out comes into picture, because whatever data I am giving inside, the same data has to come out, isn't it? So those parallel patch cords will actually help out. You'll be learning about these patch cords when you actually get into your practicals. Now what you're doing in your practicals is you have just one uh, at one point you are connecting a cable, isn't it? At one point, just at one point, and from the same cable, from the other end of the cable, you are connecting to another point, isn't it? your IC trainer kit. You're able to recall? Yes, able to correlate